Alright, here we do. We're going to do 9, 12, and 7. Let's go in that order. Let's do number 9 first. So it says, perform the indicated operation and write the result in standard form. So here's the problem. 6 minus I squared. Alright. This 5i is not that big of a deal. We'll just wait to the very, very end and multiply it by 5i. We're not going to mess with that just yet. Here's what we want to really concentrate on. Okay, it's that thing right there. No. You don't want to, you're not solving for anything. Look, Ryan, look. It's not equal to anything. We're not trying to get rid of the exponent. It's not our objective here. Our objective is just to multiply all that stuff together. Our objective is to figure out what that's equal to. We're not trying to get rid of anything because you're not solving for anything, right? There's no equal sign. It doesn't say this is equal to something and we're trying to solve for x or anything, right? So you got to make sure you see the difference between this kind of problem and a problem where you actually have to get x by itself. All right, this is not one of those. This is just to simplify this thing, work it out into its simplest form. So what do we do with this? When you have a sum or a difference, okay, something's being added or subtracted, and is being squared, do you just square the stuff inside the parentheses? No. What do you do? What do you do with any number that's being squared? No. Right, you're going to FOIL it. You're going to multiply it by itself, right? Has anybody been here all year? This is very depressing. Okay, I just feel like I'm wasting all my time, and we've talked about this a lot. All right, I'll keep going. Watch. You got to multiply it by itself. So it's 6 minus I, and then another 6 minus I. And now, again, forget the 5i till the very end, okay? Just multiply these parentheses together. That's the easiest thing to do. So I'm going to keep this a 5i. Let's multiply these together. Well, it's a perfect square. So we just do FOIL method, right? So this is times, and then 36. And then that's the first. What's the outside? Negative 6i. I'll do every little step here, okay? There is little tricks you can do since you know it's a perfect square, but it didn't seem like many of you even knew to change this into this, so I'm not even going to go through the little tricks. Let's just do regular basic FOIL method. So that's 36, that's negative 6i. The inside is another negative 6i, right? And then the outside is plus I squared. Make sense? Again, don't do anything to that 5i till the very end. Let's simplify everything inside that parentheses. Let's talk about this first. It's plus I squared. Well, what's I squared equal to? What is it? Come on, this is a fundamental thing. I squared. You should be able to just rattle that off in a second. Negative 1. I squared is negative 1. Okay, I don't understand how we're one day before the test and you don't, obviously. I can't believe we're one day before the test and people aren't answering this, like, except for one. Aubrey, thank you. So anyway, it's negative 1. So that's a negative 1. So look what I have. Let's do a little bit of this in one step. I got a 36 plus a negative 1 or minus negative 1. So what does that give us? 35, right? 36 minus 1 is 35. And look right here. Negative 6i minus 6i is negative 12i. Now, what have I been saying about this 5i? Wait to the very end. Now we're at the very end, aren't we? Now I've simplified everything in that parentheses. Now I can go ahead and take this 5i and multiply it through and distribute it correct. So, I don't know, what's that? 115 or something like that? Is that what it is? 35 times 5 is 175? Okay. I don't know what I was thinking. Oh, I know what I was thinking. I forgot something. Okay, here we go. Minus what? 5i times 12i, which is 60i squared, right? That would be a positive 60. So it's 175. Watch. Because I squared is a negative 1. Minus a negative 1 is the same as positive. Just plus 60. Is that the form we wanted in? The question says write it in standard form. Is that standard form? Right, standard form, the real goes first and the imaginary goes second. So if you circle that, I'm marking it wrong. Because what does the instruction say? Write it in standard form. So you have to write it 60 plus 175i. Is that the answer I read off? Okay. That's it for number 9. So really, the only thing hard about number 9 was understanding that you had to do the FOIL method, I think. Then the I stuff, you gotta have the I stuff down. Okay, there's a lot of questions with this I. So you gotta know that I squared is -1. You have to know to put it in standard form. Right? The rest of it's easy. I mean, working with I is no big deal, is it? I don't think it is until you get an I squared. You have to change that to a -1. You just work with it as if it was a variable, right? Until you see an I squared or an I cubed or something like that. Okay. Yeah, I do too. I don't know why people have so much problem with the I stuff. It's just a couple little basic things. Basically, it's this thing right here, right? If you know this, you can work almost any of these I problems, and it's really not that big of a deal. All right, let's do number 12. Yep.
The answer you gave us is 195,
Mm-hmm.
but we get, so every time I do it, I get 195.8. So would you want us to like round it up?
Oh, that's what he said.
I said 195.8.
Oh, you did?
Yeah. But you can make it 196 if you want. That's fine because it doesn't say to round it. So you can just take it to the nearest degree. That's perfectly fine. Let's see. What did I say we're doing? 12? Okay. 1 minus 4i. 5 minus 9i. Alright. There's a key to this problem. First of all, why is this not simplified? You can't have an I on the bottom, right? Okay. The term is rationalizing the denominator. Okay. I don't even care if you know that phrase or not, but that's what we're doing. We have to get rid of that I. Now, it's part of a sum, though, isn't it? So we can't just multiply the bottom and the top by I. That's not going to get rid of the I. What do I multiply the top and bottom by? Not the reciprocal. The conjugate, right? The conjugate. Okay, and what is the conjugate? It's the same thing, we just change the sign in the middle. Looks the same exact way as this does, except instead of a minus, it's a plus. Now you multiply the top by the same exact thing. Why can we multiply the top and bottom by the same thing? What's up with that? That's right, it's exactly right. It's like multiplying by 1, and I can multiply anything by 1 and not change the value of it. Would you agree? Yes. I would agree too. Glad you're so agreeable. Alright, let's do this. Let's do this multiplication. I like to do the bottom first. Multiplying by a conjugate is kind of easy because, I mean, you could think FOIL method, but really, what happens to the outside and inside? Alright, they cancel each other out. So really all I got to do is the first and the last. So it makes it kind of nice. 5 times 5 is 25. Now look at this. Again, if you've done these things for a little while, you should see a little bit of a pattern going on. So it's negative times positive, which is negative, but you've got an I times an I, which is an I squared, right? So you've got minus and negative, which is plus. Do you see that or not? We've done these quite a bit, where you should see that by now, okay? Because it would be a minus, but then I squared, or I times I is I squared, which would be negative. Negative times negative is positive. So really all I got to do is do what? 9 times 9, which is 81. So that was pretty simple, wasn't it? Now, the top one, I'm going to have to go through that whole full-blown FOIL method. Or distributive property, some books like to say. So here we go. 1 times 5, that's the first. Okay, the outside is 1 times 9i, which is plus 9i. The inside, which is minus 20i. And then the last. Again, let's do this. It's negative times negative, or I'm sorry, negative times positive, which is a negative. And then I times I, which is going to be I squared, which is negative 1. So really, it's minus a negative, which is plus what? 36. Good. Okay? Just trying to skip a little bit of steps. You could put minus 36i squared if you wanted to, but then you'd see that the I squared is a negative 1, minus a negative is positive, and you get this anyway. You've done these enough where you should work on a little bit of shortcuts. Alright, let's continue with this. Let's add like terms on the top here. We've got real numbers and imaginary numbers. Let's do the reals first. So 5 plus 36 is 41. And then 9 minus 20 is what? Minus 11? I. And that's over, what's that, 6106? Does anything go? No. All right, there's nothing in common with both of those that we can cancel anything out. So we're done. That's it. That's your answer. It's not so bad, is it? No, I didn't think so. I know what you're going to say. Yeah, but you've been doing these your whole life. That's true. I've been doing these a while, but I think it's pretty easy to understand. All right, what was the next one? Was it 17? 17, okay. All right, let's see. Oh, completing the square. Now, part of getting this right is by not just getting the right answer, but doing it the right way. Okay, so you have to complete it by the square. You can't, and you got to show your work. All right, so you can't just stick an answer down because I'm not going to give it to you. I'm telling you right now. Do you understand that? When it says solve by completing the square, that means I need to see that you completed the square to get your answer. So you got to get the answer right, and you have to get it by completing the square. So here's the problem. Okay? All right, let's go through some steps here. First of all, I don't like this coefficient in front of the x squared. When I complete the square, I always want that to be a 1. So I'm going to get rid of that, and I can get rid of it by dividing everything by 3. Now remember, we're dividing everything by 3, even the 0, correct? So look what happens here. That cancels out, so I've got an x squared. That's what I wanted to do, isn't it? I wanted to get that to be a 1. Plus, that doesn't go, does it? So I'm just going to leave it 16 over 3x. I like to write it as a coefficient. Okay, plus what? 2 equals 0. Yeah, you could have put it over to the other side to begin with if you wanted to. It really doesn't make much difference when you do it. Let's go ahead and do it now. Right? In order to make this into a perfect square, I'm going to take this third, or this constant, and I'm going to chuck it over to the other side. So let's write it. Leave a blank and make that equal to negative 2. I'm going to leave that blank because I'm going to complete it, right? I'm filling in the blanks, basically what I'm doing here. So how do we fill in the blanks? Take the middle coefficient. That's right. So I'm going to do this off to the side, and then I'll plop it back in here, okay? So 16 over 3, take half of it, so it means we're multiplying it by a half, and then we square it, just like you told me. Now look at this. You could go 16 over 6, but I see this, don't you? 2 goes into 16 8 times, so it's 8 over 3. So it's 8 over 3 squared. What's that going to be? 64 over 9. So that's what goes right here. So it's plus, it comes out positive, right, because we're squaring it. So it's plus 64 over 9. But can I just do that to the left-hand side? No, I got to also do it to the right-hand side. So plus 64 over 9 over here. Now, by doing this, by taking half of this middle coefficient and squaring it, I've made this into a perfect square, which means I can put one big parentheses and a square on the outside. So you got to figure out what's inside of here now. Well, what times itself is x squared? X. Always look for this sign right here that goes in the middle, and then you just basically, two ways. You could take half of this, or you could take the square root of this. I usually look at this one and take the square root of that. So what is that? 8 over 3. So that's what goes inside the parentheses. Equals. Now we got to add these up and put it right here. Well, let's put this over 1. I like to do my addition right up here in this step. All right. So common denominator. You guys watching with the fraction things? I know that's always a thorn in your side, isn't it? So common denominator is 9. 1 times 9, negative 2 times 9, which is negative 18. Do I do anything to this? No. So that just stays plus 64. What's that? 46. Is that right? Okay, so 46 over 9. Everybody good so far? And now I can go through this whole process of getting rid of the square root and then subtracting an 8/3. So let's do that. I'm going to take the square root of both sides. Taking the square to the left side gets rid of the squared. Take the square to the right side, but what has to go in front of that square root? Plus or minus. Don't forget that, because there's two answers to this, not just one. So you got to have the plus and the minus. And now I can get rid of this 8/3. This 8/3 is being added to the x. How do I get rid of that if it's being added? Good, I subtract. So subtract 8/3 plus or minus. Now look, square root of 46. Can I simplify the square root of 46? Nah, because that's 2 times 23, and I can't break down 23 at all, can I? So that's already simplified. So square root of 46 over, now I can simplify the square root of 9, which is 3. You can leave it like this, or if you wanted to, you could put it over one common denominator of 3. I don't see any reason to do that. I'll just keep it like that. And then we're done. Make sense? It's a few steps. Don't sit there and just memorize the steps. You got to be able to think about what you're going to do to go from one step to the other. Then you look at this and say, okay, what do I do now? Then you look at this, what do I do now? It's not just a matter of just memorizing the steps. Okay, you have to think about, okay, what do I have in front of me and what am I trying to do? What am I trying to accomplish and how do I accomplish that? Okay, that's what you have to think instead of just memorizing a whole bunch of stuff. Because you forget stuff that you memorize. But if you really know why you go from this step to this step, why you go from here to here, once you understand why you do that, then it's easy to do these problems. It's easier, I should say, to do these problems. Okay, do we have anything else on this review test? We've got plenty of time. 16? Okay. 14 and 16, okay. 14 and 16. Let's do 14 first. Well, 14, look, 14 is basically this problem right here. How did we solve for x once we got to this spot? Took the square root, put a plus or minus, and then I subtracted an 8/3, right? 14 is exactly that problem. Well, not exactly, but it's actually even easier. Right. Okay, so watch. Square root both sides, it gets rid of this. Square root this, but always put a plus or minus, because that gives you all your possible answers. Subtract a 20, so x is negative 20, plus or minus square root of 49, which is 7. Don't leave it like this. That's not simplified. It's negative 20 plus 7, and it's negative 20, what? Minus 7, so that's negative 13. That's negative 27. There's your two answers right there. Okay? 16. Oops. Oh, that color doesn't look much different, does it? Alright, let's take a look at 16. Completing the square again. Now they use a t. I don't like to work with t. Do you mind if I change it to an x? Minus 5 equals 0. Okay, this is actually easier than number 17, the one we finished doing just a couple minutes ago. You don't have to get rid of a coefficient, do you? It's already a 1, so I don't have to divide by a certain number. So really what I'm going to do is I'm going to take this minus 5 and chuck it to the other side. So I've got x squared plus 8x, leave a blank, plus leave a blank, and then equals 5. So I got to figure out what goes in here. How do I figure out what goes in here? Fill the space, complete the square, take half of the middle one, which gives you can do this in your head, can't you? What's half of 8? 4. Square 4 is 16. So that's a plus 16. Can't just do that to the left side. I do it to the right side as well. Now this is a perfect square. So it's going to be x plus, again, you can either take half of this or the square root of this. It's going to be the same exact number. So what is it? It's 4. You guys are too slow. Alright, 5 plus 16, quick, 21. Man, come on, you gotta beat me one time. So what do we do here? Same thing we did on that last problem, isn't it? Okay, square root, right? Square root, put a plus or minus out in front, and then do what to the 4? Subtract a 4. So x equals negative 4 plus or minus square root of 21. That's all there is to it. So look, this problem that we did right here, that included a lot of things, didn't it? It was completing the square, but also gave you the situation right here. It's basically like a combination of these two things that we did here. What else? You okay with quadratic formula? You got it memorized? Okay. I think you've asked all the good ones. Number 8's FOIL method, right? We did FOIL method today already. Should now do that. 7 is not multiplication, is it?
No, it's just subtract.
Right, you just subtract. So you change the signs in the second parentheses. Okay, and then you just add them, all the like terms together, putting the reals first, okay, and the imaginaries second. You okay with the Celsius and Fahrenheit temperature thing? Okay. What about 2? Number 2. Yeah, cross multiply. Yep. Make sure you distribute, right? Put parentheses around the z plus 7 and the z minus 2, and then go ahead and work them out. It's good. What about 20? Did you get the answer to 20? Let's do that one. Let's go to this. No, can you see this purple? Can you say that? Okay. So A equals 5 pi a squared. Alright, and we're solving for little a. Solve for little a. Okay, it's that one right there. Well, you got to get rid of some stuff first. What do we get rid of first? Do we get rid of the square first? No. Remember, it's the opposite of order of operations. Please excuse my dear Aunt Sally. Okay, so please excuse. The exponent is first and multiplication is second. But we're going backwards, aren't we? We're trying to get rid of stuff. So we go the opposite direction of please excuse my dear Aunt Sally. Okay, so we have to get rid of what's being multiplied in this case. So which is the 5 and the pi. How do I get rid of that then? That's right. Let's go with a different color. So we divide by 5 pi and divide by 5 pi. Okay? So what do we have? We have a over 5 pi equals, look what happened here, equals a squared. You've done this plenty of times. How do you get rid of the squared? Square root. So that goes away. So we take a big old square root here, but what goes in front of that square root? Plus or minus. Do we leave it like this, though? No, because you've got something in the denominator, right, of a square root. So you can't do that. So it's plus or minus. Watch this. I'm going to split the numerator and the denominator up so that they both have a square root in it. Let's say that quick. Does that make sense what I'm doing here? It's all under one big square root. We can put them under their own square roots if we do it like this. Now look, we got a square in the denominator. We don't like that, do we? So what do? Yep. Well, it's not really the conjugate, but you just multiply by the denominator top and bottom, okay, because nothing's being added or subtracted here. So you just multiply by the square root of 5 pi, multiply this by the square root of 5 pi. Okay? And so what's that going to equal? Well, look, plus or minus, square root. Look, if I multiply two square roots together, all I got to do is make one big square root and stick all that stuff under the square root. So it's 5 pi a. I don't know, it just kind of looks nicer like that, don't you think? Putting that number first. You could have written a 5 pi, but we usually put the number out in front, so it looks a little nicer that way. Over, now watch, when I multiply these together, it's just 5 pi. And there's your answer. And that's the only answer I'm going to accept, okay, because it's in simplified form. Okay, all your answers must be in simplified form. Okay? Even though it might not say it on the instructions, it needs to be, because I'm telling you, all right? It needs to be simplified. And why does it need to be simplified? I mean, look, this is the same answer. Technically, that's the same answer as this. But I'm just trying to teach you about simplifying radicals, all right? And that's, I want to see from you that you know how to simplify radicals in the denominator and all that kind of stuff. So that's part of the problem. You got it? Okay. Have you found anything else you want to ask about?
For 3 and 4,
Uh-huh.
for 3, it is Fahrenheit, you put it in Celsius.
No, well, you're trying to find Celsius, right? So you plug it in for the F on the Celsius, yeah.
You use the Celsius equation.
Use the Celsius equation because you're trying to convert it from Fahrenheit to Celsius, right? You okay with those I to the big exponents? You getting those down okay? All right. So I to the fourth is very helpful there, isn't it? Okay. Yeah, I don't really see anything else on there that should cause you too much trouble. But you never know. You never know. All right. Is that it? Okay. Test tomorrow. Be ready.